Hey everyone, today we're going to start a 30-day challenge where every day we're going to differentiate and integrate one function a day. And then I'll try to progressively make them more and more challenging as the days go from 1 to 30. Now, I'm going to try to find those questions on my own. I'm going to try to make them a little bit more challenging day by day so that we incrementally feel more and more confident. But if you guys have questions that you think would be good questions for the videos, I would love it if you commented those questions down in the comment section. So for today, I wanted to start with something not too crazy, but also worth your time to watch. And so what I'd recommend you do is, if you're already somewhat confident in your differentiating or integrating abilities, pause the video, try them on your own, and then see if we come up to the same conclusion. So for the first one, differentiate, we're going to use the product rule and the chain rule with this one. So we're going to start with the product rule. So the derivative of the first one times the second part, right? Separate this into this and that. So the derivative of x squared is 2x by the power rule, right? The power rule says that the exponent multiplies out front and then decreases by 1. That's 2x to the 1, I'll omit the 1, times sine of 3x squared, plus, I might run out of space there, plus the first part times the derivative of the second part, which means x squared times the derivative of sine is cos, and so we'll have times cos of 3x squared. I should be formal with my brackets here. And then the chain rule, sine becomes cos of 3x squared times the derivative of the 3x squared expression. And so that means times the derivative of 3x squared. Again, the power rule, the 2 multiplies the 3, and then the 2 goes down by 1. And so we get 6x to the power of 1, which is obviously 6x. And so we can write out our nice and tidy expression for f prime of x. Our derivative function is 2x times the sine of 3x squared plus x squared times 6x. That is 6x cubed times the cos of 3x squared. And then we could factor that a little bit. We could factor a 2x out of both terms, but I think this is simple enough for our final answer, and so I'll leave it as this. Okay, that's our that is our day 1 derivative. Let me know if that's I don't know. I think that's an appropriate level to start at. Again, I wanted to make it worth your while, but not too crazy to start off. And likewise with the integration. Now, this is not a super basic integration. It's a U substitution problem. But again, if you've spent any amount of time with integrating, hopefully this is a good place to kind of get the ball rolling. So let's do this one. We're going to need, again, to do a U substitution, right? If you're only used to differentiating, you can kind of picture this as the product rule in reverse, right? If I asked you to differentiate this, you'd have to use the product rule. So integrating, working backwards, is going to be a bit tricky, right? So what we have to do is set up a U substitution where, if you have some experience with this, you'll likely see that the best idea for our U substitution is the stuff underneath the square root, namely x squared plus 3, right? Now, since we're making a change of variables from x to u, then our differential dx now must be expressed in the new differential du. And so since we have the equation u is equal to x squared plus 3, and we can differentiate that with respect to x the same way that we do y, for example. If we have y is equal to whatever, then dy dx is our derivative function. Likewise, if u is equal to some function in x, then we can differentiate du dx is equal to simply the derivative with respect to x, which would be 2x. Okay? And since we have the differential dx inside of the integral, then we can multiply both sides by dx. So these ones cancel, and so we get du is equal to 2x dx. And now the reason why that is very practical for us to have is because this x dx part of the expression is exactly what we have inside of our integral. And so we can replace x dx if we divide both of these by 2. So we have 1/2, because dividing du by 2, right, is the same as having 1/2 of it. And so 1/2 du is equal to x dx, which means we can completely replace that x dx with 1/2 du, and then we can replace the square root of x squared plus 3 by the square root of u. And so now with our change of variables, our integral becomes the integral of 1/2 du instead of x dx. So I'll put 1/2, and the du always goes at the end, okay? It's all being multiplied, so order doesn't matter. We can have the 1/2 at the end, at the beginning, du at the end, no worries. And then the square root of u, right? And this is what it collapses down to. That's not so bad, right? The 1/2 is a constant, so we can multiply that out front. And so we have 1/2 times the integral of the square root of u du, right? And now that's something we can manage. That's going to be 1/2 the square root of u. That's the same thing as u to the 1/2, right? Basic exponents. And so now integrating means the exponent goes up by 1. So the 1/2 is going to be 3/2, and then we divide by that new exponent. So we divide by 3/2, meaning we multiply by the reciprocal 2/3. And so we're going to have 1/2 times 2/3 times u to the 3/2 plus c, to be proper, right? We're evaluating an indefinite integral, right? There's no bounds of integration, and so we should have our integrating constant plus c here. That's a good habit to practice. And then we should go back to our original variable x. The only u we have in our final expression is this u, and so let's replace that u with what it was originally, x squared plus 3. And so here 1/2 times 2/3, the 2's cancel each other out, and so our final answer for our integral is 1/3 u to the 3/2. So that means x squared plus 3 to the 3/2. And again, your constant of integration plus c. And we're done. So that's day 1. Again, I hope you guys find this fun. I really hope that you pause the video and try them on your own. At the start, it's going to make it a lot more fun to watch me kind of rumble my way through these. And again, if you guys have questions that you think would make good questions for these kinds of videos, please let me know in the comments section below. Thank you so much for watching, and have a great day.